Hey everyone, today we're going to be looking at this Kobalt 40 volt lithium ion battery pack. This is one of their standard 2.5 amp hour battery packs, and this particular one happens to be dead on arrival. If I press the button, I get no indication of any power whatsoever. There are a lot of YouTube videos that talk about jump-starting battery packs like this. Generally a bad idea if you don't know what's wrong with it. So we're going to open it up, we're going to see if we could fix it, possibly even upgrade it. Let's get started. To their credit, at least Kobalt still makes these battery packs, but a 2 amp hour one will set you back $140 for a new one. On Amazon, I've seen the price cheaper at around $100, but this is on sale. A 4 amp on Amazon will set you back $130. It's actually $150. 4 amp at Lowe's is now at $180. And while they no longer sell a 5 amp hour battery at Lowe's, a 5 amp on Amazon is $214, and a 6 amp at Lowe's is $250. And I'm going to use these prices as we find out the cost for repairs on this battery depending on what we want to do. So let's continue. 4 T10 Torx screws secure the shell. We'll remove them now. I'll make sure to put the screws off to a safe place so I don't lose them. There's some clasps that run along the center of the long side of each side of this unit. You can see right here as well the slight detent. I'm just going to pry it a little bit to open one side, and then once one side is opened, it's easy to pry the other side off, removing that top cover. Put this cover off to the side. A quick inspection shows no leakage, safe to handle. I'll now remove the bottom cover by pulling down in the same way the top cover was removed. And I'll now put this cover off to the side. And we can see, as this is a 2.5 amp hour system, only half of the batteries are populated with this particular battery size. We could improve upon this if it's able to be repaired. So let's conduct a test and see what's going on. Setting my multimeter to 200 volts DC, as this is a 40 volt battery pack, I'm going to test the outer connectors, and I see we have 28.5 volts, which is definitely way too low. I'll now move the battery pack into a position optimal for individual battery testing, and I'm going to test across each cell. 4 volts, which is optimal, very good. Moving on. 4 volts, very good. 4 volts, very good. 4 volts, very good. And 4 volts, very good. Now testing the upper bank, the first battery, and we got nothing. We have an open. Bad. This problem would most definitely take down the entire battery pack alone. We'll continue. 4 volts, very good. 4 volts, very good. 4 volts, very good. And finally, 4 volts, very good. I'll annotate this bad one with a Sharpie immediately, so we'll be able to reference it later. So technically, we could replace this one offending battery at wholesale for around $7 to repair this entire battery pack, instead of spending an average of $120 to replace it. I will, however, be replacing all of the batteries in this pack, as well as doubling the size of the batteries in this pack to make a 5 amp hour battery pack with brand new batteries for more money, but still saving a substantial amount of money than buying a new 5 amp hour battery pack. So I'm going to completely disassemble everything for this video, and that includes the removal of these connectors, that circuit board in the back, the front panel, and with a small, thin, flathead screwdriver, I'm able to get these connectors started. And there is some glue on the bottom, and it puts up a little bit of a fight, but we could see that it does come out. The point is not to damage anything, so I'm gentle. And there's a second small connector out. And the third one, again, has a lot of glue on it, making it a little difficult on the bottom, but I slowly wedge it out. Scraping some of that glue away on the bottom was helpful, which I did right here, just to separate it gently. And now I'm able to pull that connector right out. The front panel will be stuck on to the end of the batteries because of the glue, so it is very gently pried off as to not break anything. There is also a thermal sensor that is still connected. We can see some glue holding that on. Now separated, we could see that it's connected right there between those two batteries, and that's where it's going to stay for now. I'll remove this piece of tape that's securing it, as well as some of that white silicon, because not only is it holding the thermal sensor, it's also holding some of my wires in. So I'm going to remove some of that now, and that's good enough to continue. 3 Phillips screws secure the rear circuit board in. I'll remove those screws now. The circuit board can now be lifted up and out of the way. Under the circuit board is some plastic insulation material that has some glue on it, and I'll gently peel it off from the back of these connectors now, placing this off to the side. Take a picture of the way these connectors are situated here, or annotate them, make a diagram before removing them. I'm even making some lines with a marker with different locations on the pieces of metal corresponding to the plastic, just for extra assurance that I don't mess anything up later. At this point in the video, I was planning on replacing all of the tin, but I wanted to try to salvage it later, so I was a little bit destructive. I'm lifting the tin up high enough to be able to get under it, and I would have used a more effective method if I knew I was going to be reusing it, like a sharp chisel and a small hammer to break off the contacts, which would have taken longer, but would have been a hell of a lot more gentle than what I was doing. And that's fine, because then we get to repair it later. A piece of foam runs across the middle of the battery pack. I carefully remove it as I will be using it later. Place this off to the side. The polarity is annotated minus, plus, minus, plus, minus. Also revealed are the screw holes that we need to separate these. A long thin Phillips driver is used for this task. And I'm loosening 3 screws. Some of them hold this top piece on, and some of them go through holding both halves together. I now want to gently pull these wires back out of these plastic looms, annotating which wires go to which looms before I do so. And you do have to raise them up a little to get it out. There's a good chance you could crack one of these plastic pieces. They're not critical, but try not to break it. First one's out. The second one, I used a screwdriver to raise it just a little bit so I could get those 2 wires out. The third one I tried to raise, and then I broke it. So yes, they're very fragile. With those cables out of the way, the pack is able to bend open from the center like an accordion. If I was just removing that single battery, I would have been working from the other side and only taking apart half the battery pack. So I'm removing everything because I'm replacing all batteries, and I'm lifting this up to have something to grab. And again, if I thought I was reusing this tin, I would have been much more gentle with these pieces than I am in the video. There are many non-destructive methods to remove these that take longer than the percussion method that I'm using. But with the last one removed, the packs are separated, and we can take this plastic cap right off once we remove that one screw that was on the other side. Checking now that all screws are gone from both sides, I pull the cover right off, leaving the old batteries in their old position just as a safeguard. Put this cover off to the side, and I just want to slide out these 2 batteries so I can twist them apart. And with them twisted apart, I gain access to that thermal sensor, which I'll pull off this battery. Now put these batteries right back into the case. And just taking a moment to clean off the thermal sensor because it will be reused. And that's just fine. Now this front cover can be put off to the side. Taking a minute, I just take my knife to score off some of that old glue so everything will fit better during reassembly. My package of 20 batteries has arrived. We'll open this up right now and have a look. Just have some cases and some warnings and some paperwork. And then obviously the batteries themselves, which will open up in a separate box. There they are. Same specifications as the original Samsung 2500 mAh. I swapped them out one by one to ensure I don't make any mistakes. These are the 20 amp rated 2500 mAh batteries. Just to clarify that, link will be provided below. And once they're swapped out, just like that, I'll be putting in the second row, doubling the total capacity. Everything's looking real good. Placing the plastic cover back on, it's keyed so it only fits in one direction, making sure it's fully seated. I will then go and put the screws back in that closes those two covers together. Flipping it upside down to gain access to the other screw, which I will then tighten down. And this half's done. Looking good, real easy. We'll go and put this thing off to the side and move on to the other half, which is a little bit more involved. On this side again, we're going to be annotating the location of these metal pieces. We can see this long one right here with the black wire. Then there's a gray one, and then there's a red one. And if we look under there, there's two red and white ones coming up for reference. And then we have a blue one over here, followed by that white wire. What I'm going to do is raise all these up to give me some room to work. Make sure nothing shorts out. And we'll continue. With all the pieces removed, just as before, I'm able to access the Phillips screws which hold these two parts together. Turning it over, and under the circuit board, I'll remove this piece of insulation material on this side. And again, I'll be annotating these pieces, blue and black, and that long one. This time I'll be using a blue marker, using different reference points again. Horizontal and vertical, and then this one I'll make like a little V right here, and that should be sufficient. Working my way down the line, I'll lift up the tabs to give myself a starting point before I rip them off the batteries without mercy. Again, there's a better way to do this. I'm just not doing it because at the time I didn't care. Pulling off this last one reveals that final screw that I need to access to separate the shells. I pull off the cover, revealing the batteries, put this off to the side, and now I could start replacing these, swapping one for one. This will be followed by my new second row of batteries that I'll place in now. At which point I'll place that cover right back on, keyed in only one direction till it fits in nicely, and begin putting the screws back in, one on each side to secure both covers back together. And that concludes the battery replacement portion of this project, technically now repaired. I do want to check that bad battery one more time. It is surely dead, and compared to a good battery, it is good, and I will use these batteries for my separate projects. I found myself using a small hammer and a gunsmith tool to straighten out a lot of the metal which I had bent and mangled as part of the removal process once I decided that I was going to be reusing these pieces of metal. The contact points straightened out with the hammer as well as a drift. We'll now move this over to the welding bench. Here's a diagram I made of the first side I'll be working on. Links to the welder that I'm using can be found below. And the tin that it comes with is really thick, but I'm still trying my welder on the lowest settings. This is about 50%, and obviously it doesn't stick, and that's just fine. Trying it again at around 75%, and yeah, we're getting there. But this is definitely going to require 100% of the power in order to work. Also, I've tried welding closer together, which also helped make a connection, just like this. Making sure to stay on the battery, especially on the positive ones, there's less room to work. We could see I came close to the edge on that test one right there, but it does hold the batteries actually rotating at this point. I could try peeling it up to test, but we're looking good. So I'm gonna keep on doing this, and it's also important not to push down very hard on this. We're just making contact, and that piece is looking good. I move on to the next piece now with a test fit, make some more repairs, and weld it in. Obviously a bit more difficult given the thickness of this, as well as the fact that the metal was damaged. It's not new. This one I did a little bit off kilter. I could have done that better. But I'm not going for pretty. I just want a really solid connection that's going to be able to pull current without causing those connections to heat up. That's what's most important. On to the next one, not only verified with the diagram and obviously this movie, but we could see the marker that I've made on these metal pieces that carries over to the plastic, ensures me that they're in the correct position as I weld these back in. This portion is now completed. The center, white, blue, red, gray, and black will be next. And people will notice this would have been easier to chalk up in a vise before doing. However, given the length of the leads on this welder and recording it on a camera, the angle just would not have lended itself to the right angle to be able to see all this if it were up in the air on a vise and doing this at the same time. You can see I'm using either the palm of my left or my right hand to hold the piece steady as I do these welds. Luckily, this welder has a foot pedal, which makes that operation a lot easier. And because the metal is so thick, I'm using more than the amount of welds I would usually use to connect the battery. I think I have 6 on each. Lining up the cable looms from the other half with the side that has the cables facing up, we can see it goes like this. So if we bend it back this way, we can see the position that this side will be welded. This side, having no cables, is a little bit easier to weld. We have to make sure, though, that it is straight or it's not going to bend closed properly once the welding is completed. So I'm always checking my work. With everything now welded, I'll bend it back in half. We could see those 2 alignment pins that I need to set up. Pressing it together, it's now closed. Very nice. So now I'll drop the 2 center screws in to screw those 2 halves back together, securing it as one battery pack. Now back together, we're ready for the welding of the other side. The other side was done in the same manner, using diagrams that I had written down, as well as those marker markings and testing to make sure that all the pieces were fastened. Markings and pictures are important because those wires for the connectors have to point in the right direction, and now we have that final piece at the end. Everything is now welded in and secured exactly where it was taken off from. Looks good, it's inspected. We can now continue with the final assembly on the other bench. The clear plastic is inserted on the charger side. Pushing it into place with the residual glue is enough to hold it for right now, as long as it's aligned. As we put the circuit board back into position, this will hold it into place as the 3 Phillips screws are reintroduced and then each individually snug down. Not too tight, as we're going into plastic. We don't want to break anything. The cables are then put back in the looms from which they came out of. We are missing one loom that had broken off. Not a big deal, but a little bit of improv. The plastic insulator is reintroduced onto this side. We could see the glue residue from where it was taken off initially, getting it into position. The front cover is then placed back on. It just kind of rests over the front screw hole mounts, and the cables are plugged back in one by one. They're all different sizes, so they can't be mixed up. I press the front button, and we see a low charge, as we would expect for these batteries with a storage voltage. Taking a look in the back with a multimeter, going off of the outer pins, we come to find we have about 35 volts, which corroborates the reading of the front panel. The insulating foam is then placed back on where it came off and pressed down. There's enough glue residue to hold it into place approximately. Looking back at my notes, I come to find this large white wire went under the foam, not over it, so I go ahead and make that change. The battery is then placed in the charging connector side of the case to secure both the front and back cover for the next step. So we can see it drop in there, make sure the front panel is secured. I cut a piece of high temp polyester tape, which I will then use to hold the thermal sensor against the 2 batteries all the way down in between them, not on the sensor, but just below it. Placing it just like this, the sensor's in position. And with a very small dab of RTV, I place it just on top of the sensor and those 2 batteries just to hold the actual sensor in position. This will cure overnight. A day later, the RTV has cured and the cover is placed back over, making sure that everything lines up with the cover as well as the front plate, snapping it in. The top didn't go all the way in, so I snap it one more time, and now it's in. A general inspection of all sides as well as the front, Shows everything to be correctly seated, as well as the back. So now we can put in the screws. I'll drop in all 4 and then tighten them down in a cross pattern, but not too tight because it's going into plastic. Give them a final snug. And then a final inspection. Everything looks good. We're going to put this battery on the charger and supervise its charging. The green blinking light is a good sign. We'll press the button sometime later and see that there are now 3 bars on the indicator. No excessive heat is felt on top during charging. Now showing a solid green light as fully charged, we press the button and see all 4 bars lit on the battery. So things are looking good. We'll take the battery out now. Only slightly warm on the bottom, no excessive heat during charging. I'll pop the battery into a leaf blower. It's one of the more higher drawing appliances. And test it out. I'm not going to sit here with a leaf blower for 10 minutes, but we get an idea that it's working just fine and no issues. So we'll be testing it, throughout the summer and see how the battery works, but everything seems to be okay. An hour's work and $70, saved about $200 compared to buying a new one in the store. Note that I could have reused almost all the old batteries and done this for about $40. And that concludes this video on the repair and upgrade of this Kobalt 2.5 amp hour battery to 5 amp hours. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button to be informed of more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?